Hello there, and welcome back. In this video, we are going to look at the volume of composed figures. These are sometimes called composites. And all this means is that there are two or more three-dimensional shapes that are connected somehow. And we need to be able to find volume of those. These look like some of the scariest problems you'll ever see, but I think that you'll find that they're really not. You do need the three memory pieces. We've got this one, and this one. You just cut them out and paste them down where you want them. So let's start with this shape that looks like an upside down T and see if we can calculate the volume of this shape. So the first thing I'm going to do is to draw an imaginary line. Now you can draw it this way. See right there where I've drawn it. Or you could draw it this way. It makes more sense to me to draw it the first way because that, for one thing, I only have to draw one imaginary line. And that's usually a good rule of thumb if you can get away with just one. So I'm going to put it right there. And essentially what I've done is to divide this composite shape into two shapes. So let me color this one for you. We've got this box that's up here. And I know my coloring takes forever. If I make my crayon any bigger, then it runs everywhere and I can't stay in the lines. So I apologize. I won't color the bottom one. But this is the top box. It's like a box on a box. Maybe they're glued together for some reason. These are pretty small boxes because the dimensions are in inches. So there is one box and then there is another box down below. So can we agree that we have two shapes? We have the top box, which I've colored the yellow box. Top and bottom, you could say, or yellow and gray. So I need to find the volume of both of these, and then I would be able to tell you what the dimensions would be. Okay, I know the width of this yellow box. They give that to me. I also could tell you this dimension because I can tell you this dimension. So this is 2 inches. Then I need to find the height. How tall is this yellow box? Well, from this whole thing right there is 3 inches, but I need to take out whatever that is, and I see that that's 1. So 3 minus 1 gives me a height of 2 inches as well. So for the yellow box, I'm going to say volume is length times width times height. Volume is 2 times 1 times 2. So the volume of that yellow box is 4 cubic inches. And then I'll do this again for the gray box, the box at the bottom. And this one's already done for me. It is 4 inches long. It is 2 inches wide and 1 inch tall. So 4 times 2 times 1, that's 8 cubic inches. And when you put those together, sorry, I jumped the gun, add those together, you get 12. So the composed volume is 12 cubic inches, or 12 inches cubed. Okay, the next one. Let's imagine that this one is maybe a concrete block that has a hole cut through it. Looks like a child's toy at 10 centimeters. It could also be a part of a machine. So we have this cube, and we're cutting a cylinder out of it. So again, we have 2 solids. We have a cube and a cylinder. So I need the volume formula for both of those. The volume of a cube, the formula is edge to the 3rd power. And the volume of a cylinder is pi r squared h. And I'll tell you what, I'm going to move these down just a little bit. So focusing on this cube first, and I'm going to draw a cube. Because I really want you to be able to see this one. This is a little different than the one we just did. The volume part's not different. That will never change. But this one has a little twist to it. So just the cube, just this part, is 10 by 10 by 10. So to do the volume of the cube, I would say that one edge is 10, and we're going to take that to the 3rd power. That's the same as saying length times width times height. So the volume is 1,000 cubic centimeters, just for the cube. And then I have a cylinder. Let me draw a cylinder and then I'll rotate it. These are a little trickier to draw. I think I'm just going to leave it like that. Well, that's not really what it looks like, is it? I am not an artist, folks. That's close. Well, it's not really close enough. That's close enough. That's as close as I can get it. I'm going to rotate it onto its side. Whoops. Don't want to rotate all that. There we go. So here's the cylinder. That's the other solid. And they tell me that the diameter of the cylinder is 5 centimeters. The height would be whatever the width of that cube is, so that's going to be 10 centimeters. So let's calculate the volume of the cylinder itself. Now be careful here. Very, very, very careful. Remember, when you deal with circles, you need to think about radius and diameter. And I always taught my students to draw a box every time they saw a circle. The diameter of this cylinder is 5. So radius is half that. That's 2.5. So make sure you know whether you're looking at radius or diameter. That is incredibly important. So volume is pi, which is 3.14, times the radius, 2.5 to the second power, times the height, which is 10. Now you can put that in the calculator, but I strongly encourage you to do this extra step. Do 2.5 times 2.5 to get 6.25. And then bring down the rest. Now put it in your calculator. 3.14 times 6.25 times 10 equals 196.25 cubic centimeters. So I've got the volume of the cube and I've got the volume of the cylinder. Here's my question to you. Do I add them or do I subtract them? In this one, we added them because they were stuck together. In this one, we're going to subtract because the cylinder is actually cut out of the cube. So you would want to say the cube minus the cylinder leaves a composite volume of 803.75 cubic centimeters, or centimeters cubed. That is the composite volume that we're looking for. If a shape is cut away, you subtract. If it's stuck on, you're going to add. Okay, one more. And this fellow looks scary as all get out, but we can handle this. We can do it. Here I have a cone. But you got to realize, no, never mind that. Here you have half of a sphere. That's a hemisphere, half of a sphere. And in the middle, what do you have? That's a cylinder in there. So I think what I'm going to do on this one, if my computer will allow me, and you'll bear with me, let me go ahead and finish coloring this since I'm in the middle of it. And I'm going to make another copy of this one, if it will cooperate. Oh, it did. And then I'm going to erase what I colored there, because we're going to deal with that up top. And then here I'm going to put in this cylinder so you can see that one. I'm telling you guys, coloring things will help you so much. It helps you to visualize, especially if there are many parts or many steps to something. You see how when I color it, that cylinder just pops right up there. And it is going to be the third shape. So in this particular composed volume problem, we have 3 solids to deal with. But we know formulas for each of them, and that's going to help tremendously. So we have a cone, a half a sphere, and a cylinder. So let me put the cone up here. We have half a sphere. And then down here we have a cylinder. So we're going to need 3 different formulas. And I'm going to start with the cone. It doesn't matter which one you start with. But the volume of a cone is 1/3 pi r squared, I believe. Let me double check that. I know we did a page of those, but let me just Google. I don't use these every day, and it's the exponent. I can never remember if it's a 2 or a 3. So I'm looking for, it is the squared. But we also have a height with a 3-dimensional shape. Okay, so let's take a look here at our cone. The height of the cone is going to be from here to here. That's height. The radius of the cone would be from here to here. That is radius. So I need to figure out those dimensions before I can do anything else. So looking at this, I can tell you that the diameter is 6 centimeters because of this thing. So 6 centimeters cut in half gives me a radius of 3 centimeters. And then the height, they told me right here, but that's the same distance. So the height is going to be 5 centimeters. And with that information, I can find the volume. So it's going to be 1/3 times pi times the radius, which is 3 to the 2nd power, times the height, which is 5. Go ahead and deal with the exponent. 3 squared is 9. And then bring down your other stuff. And if you have the calculator, go ahead and use it. If your calculator won't do fractions, here's what you do. Do pi, 3.14, times 9 times 5, and that's 141.3. Then divide by 3. Cut it in thirds. And you get 47.1 cubic centimeters. So there is the volume of the cone. Okay. Then I need the volume of a sphere. And let's see if your poor old frazzled teacher can remember the volume of a sphere. I know it's 4/3. And I know pi is involved because there's a circle. R, I believe it's cubed. Let me check that before you write that down, though, because we need to be sure that I'm using the right formula. If you don't use the right formula, you won't get the right answer. And that's it. Okay, so again, looking at the sphere, the only thing I need to know is radius. And we already know that because we found it for the cone. That is 3 centimeters. So I have 4/3 pi r to the 3rd power. 3 to the 3rd. That's 3 times 3 times 3. That's 27. And then multiply using your calculator. The Casio will do that for you. 4/3 times 3.14 times 27 is 113.04 cubic centimeters. So far, so good. We have found the volume of both the cone and the sphere. Now, be careful. Do we have a whole sphere? No, we only have half. So we need to cut this in half, which simply means divide it by 2. So 113.04 divided by 2 is 56.52 cubic centimeters. So I'm going to count that as the half of a sphere. And finally, we have this little cylinder to do. I like cylinders. Volume is pi r square h. And just let me check my formula. Yes. So we need the radius, which we've already found 1,000 times. That's 3 centimeters. And the height of the cylinder. Now, be careful with the height of the cylinder. It tells me that this whole distance is 16. The cone is 5. But what about that sphere? How am I going to know how tall that sphere is? Right here. How in the world am I going to know that? Oh, but I do know that. Because this is a radius. And we know the radius is 3 centimeters. We know the height of the cone right here is 5 centimeters. So we just need to figure out what's left. So we have 16 for the whole thing, minus the cone's height and the sphere's height. So 16 minus 8 leaves a height of 8 for that cylinder. So I have volume equals pi r squared, and then the height we found down here is 8. Deal with your exponent. 3 to the second power is 9. And now put it through your calculator. Pi times 9 times 8 is 226.08 cubic centimeters. So that's going to be the volume of this cylinder. So the composed volume is going to be the cone plus the half of the sphere plus the cylinder I'm going to add that on my calculator. If you had to do it by hand, you need to line up the decimals. I got 329.7 cubic centimeters. And that, my friends, is the answer. They should not get any more complicated than this one. I would be very surprised to see this one on a test simply because it takes so long. But it's good to think through On the college level, you may have those very complicated ones. But those are volumes of composed figures. And in the next video, we will practice with that a little bit more. I hope you have a great day, and I'll see you soon. Bye-bye.